Okay, so good afternoon, everyone. I am Alex Tennant. I'm a Salesforce MVP and developer based in Bristol, and I'm here today to talk about unit testing, or rather, writing true unit tests and using dependency injection and mocking to do that. So this session isn't going to go in depth on how to use things like Apex mocks, but I am going to talk about it. What I'm going to talk about more is the concepts around what a unit test is, as opposed to what some people think a unit test is. A little bit of theory around what dependency injection and version control, mocking and stubs are, and what the advantages of using those approaches are. I'm then going to show you how to put that into practice and then talk about some of the ways you could actually apply this to your code. So there is code in this presentation, but it's not code I would use in production. It's purely there for the sake of example. This is more about making sure that you've got a firm grounding in why these things are important and to help you improve your testing. So the four things we're going to cover, I'm going to talk about unit testing in general to start with. Then I am going to go through the theory of those various bits that I mentioned already. I'm going to talk about how you can actually apply these theories to your code, and I've got a few examples that we'll go through. And then, as I say, finally talk about some patterns and frameworks. So it's the end of the day, and I'm sure you'll just want to sit down. But first of all, can you all just stand up for me, please? Just get a little bit of energy before I carry on talking. This is the only bit of interaction I'm going to have, so don't worry, I'm not going to do any more than this. If you know what unit testing is, stay stood up. Okay, that's a good start, because if you didn't know that, then this probably isn't for you. If you've ever written a unit test, stay stood up. Okay, also good. If you think you couldn't improve how you write your unit test, stay stood up. Okay, no, this is good. This is good. When I did this at Dreamforce, we had 4 in a room of about 200 that stayed stood up, and 2 of them very swiftly sat down when they realized there was only 4 of them. This is good. I mean, even me standing up here doing this, I know that I could improve how I do my testing, all of my testing, not just my unit testing, and it's good that obviously people recognize that. If you sat down just because you saw everyone else sitting down, then, maybe that's a bit different. Anyway, so unit testing. What is unit testing? Well, I've nabbed this quote off the internet. Hopefully you all know, but I will be referring to some of the bits from this. So unit testing is a software development process in which the smallest testable parts of an application, called units, are individually and independently scrutinized for proper operation. And the emphasis is important there. We'll get onto that in a bit. Now, the other kind of testing that people are familiar with is integration or systems testing. The integration testing is the phase in software testing in which individual software modules are combined and tested as a group. It occurs after unit testing, generally in the software development process. It doesn't have to, but generally. And before validation testing, so where you get your users to go in and actually do some validation on what's going on. So just to summarize those 2 quotes into a couple of short lists, there's more to the 2 things than this, but for the purposes of what I'm talking about, this will do. So unit tests test the smallest testable part of an application. So that could be a method. Most cases, it probably will be a method. It's unlikely to be an entire class, because your class is probably going to have at least 1 method in it. The modules are tested independently. So various bits that you depend on should not influence the outcome of your unit tests. I'll talk about that a bit later. And they're primarily intended for the benefit of the programmer. Unit tests, they're testing things that you care about as a programmer. They're not testing things that end users care about. End users care about, I click the create new invoice button and I get a new invoice. The mechanisms of that are not important to them. So we're testing things that programmers care about because we're testing these little individual parts. So integration tests, or system tests, test the real-life operation of the system, because you're testing all of the parts working together, or you should be in an integration test. So following on from that, they test the application as a whole and also how multiple modules work together. Now, this last one's a bit of a funny one, because your integration tests are still going to be written in code, and they're not actually going to be understood by non-programmers, but conceptually, an integration test is more likely to be understood by a non-programmer. If you explained what the test was trying to achieve in the, say it was a visual force page controller test, and using the example I used a second ago with the invoice, that this test is when the create invoice thing happens, an invoice is actually generated. Conceptually, that's something that an end user would understand, while they may not actually understand the code itself. So I'm going to talk through a little example of unit testing. So I've got a couple of classes here. I've got my controller up the top. Pretend it's a page controller, not really relevant. It's a controller of something. And I've decided to go for a little SOA type architecture. So I've got a service down the bottom that just abstracts away a query. For those unfamiliar with SOA, service-oriented architecture, the reason for doing this is because at this point, my information comes from a SQL query. But in the future, it could equally come from an API call to an external service. By abstracting this away, I can change this bit freely without having to faff around with everything that depends on it. And that's a key point in what I'm going to be talking about later on. So I've got my two classes, nice and simple, SQL query, something that basically returns that information. And I have written a unit test for my controller. So a very simple unit test, two tests, one that checks that the whole thing doesn't fall over when there's nothing in the database, and one that checks that some stuff actually comes out when I do have records in the database. So I did lie. There is one little bit of interaction left. I'm not going to make you stand up, don't worry. But what do people think of this as a unit test? Do people think this is a reasonable unit test? That's the right answer. Exactly. Which I'm hoping that people realize based on the slides before it. So it's not an integration test. Sorry, it's not a unit test. That's what I meant to say. Because it doesn't test the smallest testable part of the app. Because the two things are tested in tandem. And so likewise, the modules are not tested independently. It does test more like the real-life operation of the system and the multiple modules working together. Now, the reason I've done that example is because a lot of the unit testing examples that Salesforce provide, they're not unit testing examples. They're unit testing in that they will run as unit tests on the platform and count towards your code coverage, but they're not unit tests in the strictly engineering sense of the word. So it's a little bit of a fudging of terminology that Salesforce have used. So I'm going to talk a little bit of theory now. So I'm going to start off with inversion of control. And this little bit of theory is just to set the stage for when we talk about mocks a bit later on. So inversion of control is where you separate the what to do part of your code from the when to do it. So similar to where I've separated out the service there from the controller defines the order that things happen. In this case, it's very simple because all it does is goes off and gets something and returns it. But it could be it goes off and gets something from somewhere, sends it off to another service, and then finally returns that, or it could do a whole bunch of other operations. So you have the when to do, which is the controller, and then you have the what to do, which is your services. And separating them out is inversion of control. There's various different specializations of inversion of control. The one I'm going to talk about is dependency injection in a second. And generally, with inversion of control, the responsibility to decide what to do is given to the client. And the client in this case is whatever is constructing, in this example, the controller. So it will say, in the case where you're going to, in this example, get bacon, I want you to get the bacon from here by giving it a particular service or whatever else through some mechanism. So the advantages of this approach are that it promotes decoupling of your code because the idea here is that you code against an interface. In Apex, that would be an actual defined interface because then you can actually swap out these implementations. If it was JavaScript, for example, you don't actually need a definition of your interface. You could just pass in an object that provides the appropriate methods. So when I say interface, In this case, I'm not talking strictly the keyword interface, so you get an Apex, Java, C#. It's just about having this expectation that if I do something, in this case get bacon, I will get a list of something that I expect back. And it allows your code to be more flexible by facilitating the easy swapping of implementations, and this is what mocking is about, but also you can use this at runtime. So it could be that for certain users in your org, talking in Salesforce context, you want to return different data in this scenario or run slightly different queries due to access levels or what they're interested in or whatever else. And by moving the definition of the queries and when they're run out of your class, you have the opportunity to be able to manipulate that based on different factors. So dependency injection is a specialization of inversion of control, like I mentioned before. And with dependency injection, this is where you don't explicitly construct, so in this case the service was constructed in the other example, the dependency within your class, your controller, you inject them via some mechanism. So there's two simple versions of this. One is constructor injection, where all of your services or your dependencies are passed in the constructor. And this is how Angular does it, although it uses some clever service locator patterns to actually grab those and put them in for you. You don't have to do it explicitly. But then there's also getter and setter injection is another example, which is used in Spring Batch in Java. You can use constructor injection in Spring Batch as well, but people tend to write it as getter and setter injection, or at least they did the last time I used Spring Batch, which admittedly was quite some time ago. Yeah, so the idea here is that you're actually passing things into your class and saying, use these things to do what I need you to do, not the things that you've got hard-coded in you. So it gives you that bit of flexibility. And I'll show you an example of this in code in just a second, in fact. So, oh, I've gone 2 slides there. There we go. So, okay, based on inversion of control and dependency injection, how could I refactor the example from before to make use of them? Well, the first thing is I'm going to create an interface, an actual Apex interface for my bacon service, just to say, right, this is my contract for, grabbing bacon from somewhere. Then just going to quickly refactor my original service to use the interface so that wherever I'm asking for an instance of an iBacon service, I can pass in that particular one. I'm then going to quickly refactor my controller. And in this case, I'm using constructor injection. So as you can see, rather than newing up a bacon service inside my class, I'm leaving the responsibility of that to the caller or the client to actually pass that into my constructor. So that means I could pass in the original service I've got. I could create some new service that goes and does something completely different, like say goes and gets an API. But this controller will always do what it's meant to do, which is basically go off to the service and provide the answer back to the user with no manipulation in this particular case. But it could be that you were doing a manipulation, as I say, or you were passing it off to another service. So moving on to actually what the meat of this is, which is talking about testing. There was a point to all of that refactoring and everything else. Once you've abstracted away these things, you can actually start to then stub them or mock them. So stubs and mocks allow you to basically put in fake implementations of your dependencies so that when you're testing things, you are actually only testing the function of the bit that you dependencies rather than the dependencies themselves. So stubs are generally very simple. They tend to just return values to clients. They're not particularly smart. They're quite helpful for doing, very quick tests and all the rest of it, and for just passing data around for things that you've already tested. Mocks are like stubs, except they're more complex. So mocks are generally more flexible and easier to reuse. And also, part of the definition of a mock is that it actually performs some kind of verification. So it could be verifying the input parameters on a method. It could be checking how many times a method is called during the execution of something in particular. all sorts of things, and most mocking frameworks will do all of this sort of stuff for you. I mean, you have to tell them, obviously, how many times you expect something to be called and everything else, but Mockito and Apex Mocks, which is one for Salesforce that has been built by Financial Force, have a verify method that basically will check all of these things that you say should have happened at the very end of it. So how can we actually apply this to our code? Well, what I'm going to show you is some very, very basic, and as I say, this is not production code that you should be using, but very, very basic stub and mock implementations that have just been written straight in Apex. If you're going to do this properly, I would say use a framework, use Apex Mocks, use this new stub API that's coming out. These are just here for the purposes of examples, so you can see how these things, in a very basic level, would work internally to hopefully demystify a bit about what's going on. So the first thing I'm going to talk about is a stub. So I've got a test class, and I've created a couple of stubs for my service inside there. So they're both very simple. I've got the no bacon service, which returns nothing, and I've got the streaky bacon one, which returns the same as my test did earlier, so just one object in the list. How can I actually use those to improve my tests? Well, now that I've done the refactoring, where I can pass the different versions into the constructor, I can now actually use these stub implementations directly in the tests. Now, so you'll see that both tests have changed ever so slightly. This one no longer inserts anything in the database, and this one obviously takes the no bacon service in the constructor. Now, why is this a good thing? Well, purely and simply, it means I'm now only testing code that is within the controller. I'm not testing code that's in the service. Fine, in the normal operation of the system, it will do a SOQL query and it will go and get the data. But if I decide to change that in the future, this test will not fail. These tests, rather, will not fail, which is a good thing because the behavior of the controller hasn't actually changed. The behavior of the system as a whole has. So my system tests and my integration tests would fail, so my original ones way back at the start, but the unit test shouldn't fail because I've not changed anything in the controller. There's no reason for it to fail. So let's improve this. Let's move on to making a very, very basic mock. And as I say, don't use this in a production environment. This is just meant to sort of demonstrate the sort of stuff that's actually happening within a mock. So there's a couple of little bits here. I've got this mock method here. So what this allows me to do is actually change the parameters that, change the return value of the method that I'm actually mocking. So this is the flexibility I was talking about earlier. So I can use this mock to perform both of the tests that I did with two separate stubs earlier on. It also does some very, very basic verification to check that actually the method was called, because theoretically, the controller could just return a hard-coded list to pass my original tests. That's not really what it's meant to do, though, because its purpose is to use the service to get the information it needs. Its purpose isn't just to return this one-item list or a no-item list. So how can I use that in a test? So I've just quickly refactored these two tests again. So I set up the mock as the first line in both tests. So in this one I'm saying, right, return me an empty list. In this one I'm saying, right, return me a list with one item. And then the rest of the test looks exactly the same as it did before, with the exception of the fact that I put the verify lines in. So you'll notice on the other slide that the verify actually does a couple of quick asserts. It just checks that these two sets match up, so you can check that all the methods you expected to be called were called and none that you didn't expect to be called were not called. With one method, obviously, that isn't really necessary, but it just shows how that could work. So again, if I go and change how the service works, controller tests will still pass, which is great. And also I'm actually verifying that the correct things are happening. Now, there's a few other advantages to this as well. One, it allows you to write SOQL-less and DML-less tests. So if you abstract away your SOQL and DML operations into services, then it will allow you to write tests where you never touch the Salesforce database for unit tests, which is massive in terms of performance. When you end up writing proper unit tests, and you've got probably at least 2 tests per method, if not more, you'll end up with hundreds and hundreds of tests in your org or your managed package or whatever else. And if you're touching the database every time, they can take a long time to run. And for every single unit test, it's unnecessary to be touching the database. For your system and integration tests, you do want to be touching the database because you want to actually check the data is coming from the right place and everything else. But for your unit tests, it's not necessary because you're just checking the program flow throughout the code, really, and checking edge cases and all of this sort of thing. So I've shown you how not to do it. I'm going to talk a little bit about some of the patterns that I've mentioned as I go along, and then I'm going to show you a little slide with a few frameworks that are already out there for actually doing this. Because if you are going to do it, as I say, don't roll your own. People who are very, very smart have already done a lot of the work for you. If you really need to roll your own, you really feel the need, feel free, but you will waste hundreds of hours on it for probably very little benefit compared to just taking something off the shelf. It also means you've got to maintain it and update it and everything else. So anyway, on to patterns. So I mentioned constructor injection earlier. So we've already covered this one. Basically, constructor injection is I pump all my dependency in through the constructor. It's very simple to reason about. You know, you construct a class, you give it everything it needs to begin with, and then you can get going. We then also have setter injection. So this tends to be used with, say, frameworks. So this example is actually in Apex, but you probably wouldn't use it in Apex because it'd be a bit of a pain to get going with. It tends to be used with things like Spring, where you can say, right, I've got this dependency and I want you to use this setter to stick it in. And automatically, when it constructs an instance of that class, it will call all the setters and pass all the dependencies in. It is common in a few other DI frameworks as well, not just Spring. But yeah, basically, rather than using a constructor, you use setters to pass in each of your dependencies. There's an advantage to this in some use cases because you can keep an instance of a class around and switch its implementation during its lifetime without having to new up a different instance of it. So if you've got a use case that involves that, then maybe setter injection would work for you. Now, there's a couple of more complex patterns around actually grabbing these dependencies, because you're probably thinking, my constructors are going to get massive, I'm going to have tons of setters, blah, 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 for putting all of these things in, and it's just going to be an absolute pain in the backside. Well, there's the main one that I want to talk about is the service locator pattern. So this delegates the lookup and construction of services to a service locator. So, for example, you will at some point register all of your services. You'll say, when I want a iBacon service, I get an instance of this class back. When I want some other service, I get an instance of this class back. And then within your clients, you will go, right, service locator, get service, or whatever you've named it, or whatever the framework you're using does, and it will bring you back what you require in that situation. Now, the good thing about things like service locators is you can then expand that and start looking at storing dependencies in configuration. So you could have a custom setting, you could have a JSON static resource, XML, whatever you want, that defines all of the dependencies and perhaps has different sets of dependencies for different situations. So, you know, like I said earlier, it could be a per user context. It could be that, say, the directors have a different set of dependencies because different things happen when they interact with parts of the system. It could be per role. So finance, for example, get different things. Or it could be per context. So if you're coming in from the sales app into an area, you could get different information from if you're coming in from the finance side of things, while still using the same fundamental controller and everything else. Now, per context is probably not something I would recommend, but there are definitely use cases for it out there. So with going back to the service locator pattern, What this allows you to do is, rather than explicitly registering all of your services at the beginning of a transaction or whatever else, at the beginning of the transaction it goes, right, I'm running in this context, or I'm running as this user, grab their configuration, register all the services, and then your code doesn't care. It just goes and grabs them and goes, oh, right, this is what I've got to use in this scenario. Away I go. So, frameworks. There's quite a few out there. The first two are Salesforce specific. So we've got Apex Mocks, which is based on Mockito, which is a Java framework. It's open source and it's built and used by Financial Force and a few other companies as well. It supports quite a few features you'd expect from a mock framework, so verification of method calls, arguments, you can stub methods, you can throw exceptions in your mocks as well. That's one of the things I didn't show in my very basic example. Rather than returning a value, you could mock something or stub something to throw an exception to test that particular code path. And at the moment, it uses a small Java program to actually generate the mocks. So there's a whole bunch of classes that make up Apex Mocks for doing the validation, the stubbing, the mocking, and all of that. And then what you do is you give it a list of interfaces you want to generate mock classes for, and it will generate a class that has mocks for all of those interfaces for you. Pop that in your org, start writing tests. The other one that's very interesting is the stub API. So this is something that Salesforce are providing. It was a pilot in winter 17. It is being made GA in spring 17. And it provides native interfaces and methods for actually generating mock and stub classes. There's, I'd say, more details in the winter and spring release notes. There are scant details in the winter and spring release notes, but I'm sure if you go and poke Dave Carroll or Peter Chittum or some of the other developer people who are around today from Salesforce, they'll be able to give you a bit more information. You can also poke around in the stub API branch of the Apex Mocks repository, where they've already done some work to start using the stub API with Apex Mocks. So effectively, they've built more features on top of the stub API. And then if we're looking at other platforms, you've got Mockito in Java, which I mentioned before, Jasmine for JavaScript, the unit test.mock module in Python, mock with a Q in C#, and many, many more. I mean, this is just a small example of ones that I've worked with and familiar with, but there's hundreds out there. I wouldn't go as far as thousands, but there's certainly a few hundred different mocking frameworks out there for pretty much every platform you could want. So, to summarize, why bother? Now, it seems like a lot of work, and it is a lot of work, but you will get a lot of benefit out of it, especially in the longer term and on larger projects. So your tests are now protected from changes to modules they depend on, which is good, because you don't want to change one class and have the whole house of cards fall down, all of your tests fall down, and you don't actually know where the problem is. By having proper unit tests that only test the individual classes, the individual modules, you can actually very quickly identify where the problem actually is, rather than having a whole stack fall down. Your tests now only actually test one thing and are actually unit tests, so going back to the definition at the very start of the presentation. But also, you get a lot of flexibility out of this, because you can swap implementations and various other bits. You might not need to immediately. You might only be, putting these behind interfaces for the purpose of testing to begin with. But later on, when a customer says, oh, well, actually, we need to go and grab this from somewhere else, it's a much smaller change and a lower maintenance overhead in the future. Now, I've talked about integration tests, and I've actually refactored my tests. In reality, I shouldn't have done that. The integration test was fine. It could have stayed there as an integration test. And you shouldn't forget about integration testing, because it is very important. It actually tests, what's going on when people use the system. And it's all well and good having your unit tests and everything mocked, and you think, oh, I've got all these good scenarios. But if you miss something that actually happens when you're using the system, say something's not actually inserted in the database, you call the service, but the service doesn't actually call insert, and things like that. You're going to miss that if you only have unit tests for testing those things. I mean, ideally, your very bottom level service that inserts in the database, you should be checking, but if for some reason that test doesn't exist, you'll actually capture these things. You'll also capture more of the flow through the system by doing integration tests. But what I would say is concentrate your integration testing on your application's entry points. So, if we're talking C or Java, that would be, main. If you're writing a C or Java set of tests, do not do all of your integration testing on main. But I'm talking about where actually people start interacting with your code, which in Salesforce world is page controllers, controller extensions, invocable methods, your REST resources, web services, etc. Don't do integration tests all the way down the stack, because what you'll end up doing is writing one big test at the top, and then the next level down, you'll cut a little bit of it out. The next level down, you cut a little bit more out. And at the very bottom, you'll cut it right down to the very basic bit. And it's a waste of time. And it doesn't actually provide any benefit going all the way down, because a user is never going to run the tiny little bit 2 levels down. They're going to do the bit where they click the button on the page and they wait for it to do the round trip all the way down your stack and all the way up. And finally, use common patterns. Patterns are good in programming. Don't be a slave to them, but they're good as having a common vocabulary for communicating with other programmers and getting people on board with your code base. But also, use a framework. If you want to roll your own, feel free, but I really wouldn't recommend it unless you have very specific use cases. But use a framework to make your life easier, and again, so that you've got a common dialect that you can use when you're talking to the rest of your team and when you're actually working with your tests. And that's me. Thank you very much. I've got, according to Simon, who just poked his head in, I've got about 3 minutes for questions, if anybody does have any. Although I'm desperate for a drink, so if they wouldn't mind waiting until I go outside and get some water, that would be great. Thank you very much. Oh, and one last thing. If you've filled in the flyer with the stickers on the back, drop it in outside the main keynote room, and there's all sorts of prizes you can win. Sorry, Simon told me to tell you all of that, but yeah. And if you haven't got all the stickers, just nip over to the booth now, and I'm sure you can get the card filled in really quickly. Thank you.